Statue of Liberty is much less impressive than I thought it would be. So.
You find that in life, when you see all these things that, you know, in books or whatever, they seem bigger than life. When you go there, they end up being smaller than what you imagined.
You know what, though? When I went to the very top of the Empire State Building, and that was freaky. You don't realize how tall that is until you get up there and you look down. Oh, dang, I feel bad for all those guys who have to stand on those poor beams making that thing.
I want to go to that place over the Grand. It's like $100 or $200. It's really expensive. It's called the. It's over the Grand Canyon, and it's made of clear glass or something like that.
Oh, yeah, I've seen that. I don't know what that is.
Grand Canyon. Look out.
What?
Look out.
I just want to run out there and be like, no, don't give it to it. Oh,
Hello.
Yes, what's up, Ben?
Maybe there's like a card.
Skywalk. That's what it is.
Skywall at Eagles Point. Walk the sky. Oh, wow. Yeah.
It's this U-shaped thing, and
That is terrifying. I read an Agatha Christie book or something like that where it was like they were walking over that and it fell.
yeah, there's the big picture. That's what it is, and it's clear glass underneath.
Yeah.
$20.
$20 to walk over.
Well, that's just to do the walk thing. To get on the property costs general admission $39. So $39 plus. It's like going to
Deep Park.
no, what's the big Royal Gorge?
Oh yeah, the Royal.
Well, I've been to, wait.
You can't. You know, it's hard to look over, but apparently this is pretty cool. They have the. You just remind me because they have a couple big buildings in New York where they have this, or maybe Chicago, where they have like a thing that you can walk out into, and it's a clear glass.
Oh, yeah, they have like those clip-on things. Yes. I went camping once, and they had like it over like a lake, and you were like on a waterfall, and you would go out, and you were in a glass dome, and it was over a waterfall.
Right.
I don't like that kind of thing because I'm always worried they're gonna crack beneath my feet. That's what I was thinking about the whole time I was in there.
They have a. There's like, they've done this in a building where they have this, and then they built like a projector underneath of it, and it turns into like it's cracking, and it freaks people out.
Yeah.
All right, homework.
Oh yeah, we did do homework.
Chapter 4 review. Where are you? There you are.
And I cut out a triangle.
Did it help?
Kind of. I didn't really get what it asked me to do. Plus, my triangle wasn't perfect, so. For number 6.
Number 6? All right, let's take a look at number 6.
It told me it says, ask what I see, but
Well, I told you that they were going to ask you to make medians and altitudes, just come to some general idea of what happens if you do all 3 of them.
I like the proofs. They were cool.
Yeah, they were pretty easy.
The proofs, I'm pretty sure I got them. I'm very confident.
All right, number 6 says, cut out any large triangle, fold the 2 corners of one angle of the triangle together to form an angle bisector. Use the same method. So, and then what they're trying to have you is that, okay, so you cut out a triangle, and then you make the angle bisector, and then you make the angle bisector, and you make the angle bisector. You're going to find out that the angle bisectors all come together.
Right, that's what well, that's what they were asking.
That's all they were asking you.
It makes 3 equal triangles.
Is that true? I'll have to think about that.
Look, because the angles are congruent, and then because the sides are congruent, and then
I'll have to think about that.
But then if it's an isosceles triangle, definitely. Because then you can do transitive.
It might be true for, equilateral, but maybe not for all. Certainly it should be true for equilateral.
Yeah.
Okay.
So I've terribly misread that. Okay.
And in fact, the answer in the book says they intersect at a point is all they were looking for.
Oh, that's what I just said it made a box, but probably because I folded it wrong.
Clearly, if you got a box out of a triangle, yeah.
But how do you get a box?
It was 15 and 17, not 15 through 18.
It was just 15 and 17. Why did I give you 18?
I don't know.
I should have given you 18.
Or you didn't give us
16. You just gave us 15, 17, 13.
Oh, I know why, because we proved those in class.
Oh.
And it was like, we already proved them, so why do it again?
So did the other class not prove them?
They didn't get those proofs.
Oh, okay.
Any questions?
Nope.
They could not get 13, and I thought 13 was the easiest one.
Number
13.
17, so theorem 4-8. So 4-8 is the converse to 4-7. So it says, if a point is equidistant from the sides of an angle, if a point is equidistant, so remember we measure things perpendicularly. So if it is equidistant, so that picture right there, then you need to prove that it lies on the angle bisector. You need to prove that it's somewhere on that line right there.
Okay, then I just prove
So
the triangle is congruent.
step number one is, while you draw this, you're not showing that it's a bisector yet. Your job is to prove that this angle is congruent to that angle, and you're done. Okay,
Okay, well, if it's a bisector, then those two are congruent.
right?
Well, I mean the bottom one and the top bottom.
Mhm.
And then if the reflexive property, and then those two are congruent because they're right angles.
You didn't tell me why the triangles are congruent.
Because of SAS.
No,
No, SSA.
no,
No, HL.
HL.
There we go.
Because remember, there's no SSA.
It's HA.
So here's the leg, and the reflexive property is hypotenuse. Therefore, those two, and you're done. That's also why, I kind of already said that in class too, as well too. All right. Anything else? All right. I'll just tell you, as always, there'll be times when I literally can show you what they're testing, and other times when it's broad general things, I just kind of gotta give you some questions. Make sure you understand fully those. It is 4 theorems right there, but it's really just 2, and the other ones are the converses. Is that if you make an angle bisector of a segment bisector, perpendicular bisector of a segment, and you're anywhere on this perpendicular segment, what can you say?
That it's equidistant to the cube.
It's the same distance from here as it is to here. That's the thing, and we got the converse of that. And the other one is, if you are on the angle bisector, if you live somewhere here, then you are equidistant to the two sides. So remember, we measure distance perpendicularly. Those are the two, and then we get the converse of both of those. And then lastly, you got to know the difference, and usually you'll have a couple kids, because it's the first time you've seen it, and it's just not in your brain. You got to know the difference between a median and an altitude.
Wait, so would you also prove that with AAS?
Which one?
That bottom one.
I don't remember how we proved it, but let's see. Let's prove it real quick.
We proved the HL.
Well, we don't have that it's here. We also we do have that, but that's all we have. So we know it's on a angle bisector. So this is the
So then
we
we have
have
to do
that.
AAS.
So we have we have AAS. Yes, we do.
But in the book, we do have the congruence takes.
Yeah, because the converse would be the other way. You start with that these are two congruent.
Yeah, which is what we had to prove.
When we proved the going forward right method, if you want to say that, But when you're proving the converse, then you're given that these are congruent. You're not given that those are congruent. All right. I lost train of thought. So you got to know the difference between a median and altitude. So pick one, and you just tell me what it is. Tell me what to draw to show me what you're talking about. Okay, so we're gonna draw an altitude. I first need a triangle, and it could be any triangle. All right, and then we need vertices A, B, C. Now what?
Now you do a perfect.
No, let her.
From A to segment.
Remember, you said you're gonna do an altitude. So what do you want me to do?
Oh, draw a line down from B,
Okay. To
the middle of AC,
the middle of AC. Okay, and you're saying that's an altitude.
the right angle.
Okay, and you're saying that's an altitude. Okay, so guess what your homework is tonight? To learn what an altitude is, because that's not an altitude. All right, what's an altitude?
It's the line that makes the right angle.
Okay, what's the difference between what you said and what she said? Because she said make it a right angle.
She said that
She
comes
said
straight
to
down
make
from
it
B.
to the midpoint.
Ah, so is an altitude to the midpoint?
No.
Not all.
Could be, right? We have not proven this, but turns out for equilateral or isosceles, if you come from that angle that is the two legs of the isosceles, or any of the vertices of the equilateral, it ends up being that's true. It is a perpendicular bicycle. We haven't proven that yet. Okay, so that's an altitude. So what's a median?
It's the line that goes from the vertex to the midpoint.
So we find the midpoint first, put a dot, and play connect the point. That's a median. Right? It may or may not be perpendicular, but it certainly cuts the opposite side of the side opposite the vertex in half. That's the difference between an altitude and a median. Altitude and median. Don't confuse that with those other theorems. So the other theorems we're talking about a angle bisector. And the only thing we get from there is that if you have an angle bisector, then any point along that is equidistant and it's also perpendicular. And then the second one is if you have a perpendicular bisector of a segment, that if you live on the point or live on the perpendicular bisector, then you are equidistant to the two endpoints. And that was all of that last section. And I'll just say most of the test comes from the very last section. The other part, it's the easy stuff. It's the SAS. I'll give you two triangles. You tell me why they're congruent. I give you two congruent triangles. You pick out corresponding parts. It's write a triangle congruency statement. I'm trying to think about the other stuff that we did in the chapter. It's pretty straightforward. But the last thing that we did, the only formulas we got were that did we get one other formula? I gotta flip the book now. Chapter 4. 2. I want to say that was it. That's it. That's it. That's it. That's it. That's it. That's it. Isosceles triangle would be the only other thing. So what's special about isosceles triangle?
The base angles are the same.
What else?
The base angles are congruent to the blade.
No.
The two base angles are
And
they're parallel.
no, nothing's parallel in a triangle.
Yes, there is.
What?
The middle line is parallel to the other.
And the two sides are congruent that are
Equilateral. Equal
That are
triangle.
opposite.
the base angles. So if you draw that's by technicality, or by that is what the definition of a isosceles, a triangle with two congruent sides. The so what is we found out that the angles opposite the two congruent sides are also congruent, and then we have the converse that says if two angles of a triangle are congruent, then the sides opposite them are congruent. What kind of this is not on the test, but we're just talking here.
So then the number of angles congruent is directly proportional to the number of sides that are congruent. Because if there's one side that's congruent to the same side, then there's only one angle that's congruent itself.
I'll buy that. Okay. This is not on the test, but what kind of isosceles triangle can you have? Can you have all three kinds? Can you have an acute isosceles triangle?
Yes.
Yeah.
Can you have a right isosceles triangle?
Yes.
What would that look like?
You would have it like this, and then
What would the three angle measurements then?
Then the angle measurements would be 90 and 45 and 45.
And can you have an obtuse isosceles triangle?
Yes, you can.
You can't. You have all three. Okay. We wouldn't say you have an equilateral or equiangular one because it would just simply call it equiangular, right? And remember, equilaterals are equiangulars. Okay. Jack, do you have any questions on this chapter?
No, I do not.
Ben, do you have any questions on this?
No.
All right. Did you catch that note I wrote you, Ben?
Where?
Where I said that you turned in the wrong homework and all you did was change the title from 4.3 to 4.4?
What?
Go on Teams and look at the feedback I gave you. You took one assignment, you changed 4.3 on the top to 4.4, and you turned that in for both assignments.
Oh, really? Oh, my bad. So I have to do 4.5 as well.
You tell me which one you actually did, and then you do the other one. I'm guessing you did 4.3 and not 4.4.
Yeah, I think I need to do 4.4.
Okay. Test this tomorrow. I'll have it posted by noon, I think, is when I have it to show up, so you can get started on it as soon as noon if you want to.
Okay.
All right. If you have any other questions, send me something.
Yes, sir.
Okay. Talk to you later.
Goodbye.
Goodness, Jack. Jonathan Jemison?
Yes.